Hey everyone, in this video we'll learn how to solve a system of linear equations. So first let's talk about what a system of equations actually is. What is a system of equations? Well, we know what an equation is. For example, x plus 3 equals 7. And we know that in this equation we want to solve for x, so we just subtract 3 from both sides. And very simply we get x equals 4. And we've solved for x, our variable, in this equation. Now, a system of equations involves more than one variable, and it also involves more equations. So an example is 3x plus 4y equals 72, and x minus 4y equals 12. So this is a system of equations. And the reason it's a system of equations is because we have two variables this time. We have x and we have y. And we want to solve for both of them. Our goal at the end, we want to get x equals something, and we want to get y equals another number. Our goal is to find what x and y equal in this system of equations. And the reason why it has to be a system of equations, so for example, if we just took out this equation for a sec, and we only had this equation, 3x plus 4y equals 72, and we were asked to solve for x and y, we couldn't do it. There's theoretically an infinite amount of solutions for x and y, but there is no way to actually solve for x and y given just one equation. We can't solve for two variables if we just have one equation. If we want to solve for two variables, then generally speaking, we need two equations. And there we go. We have both equations right here. So what we're going to do is we're going to go through a few ways together on how to solve for x and y. So one of the first ways that we will explore is addition. So what we can do is actually, let's take these two. Let me just copy and paste them down here. Let's take these two equations and let's actually just add them. Let's add them. So what do we have? We have 3x plus x. That comes out to 4x. And right here we have plus 4y minus 4y. Those cancel out. And then right here we have an equals. And what is 72 plus 12? That is 84. So 84. And then if we go ahead and solve for x, divide 4 from both sides, we have x equals 84 divided by 4 is 21. So we've solved for x, but we're not done yet. Now we have to solve for y. And how we're going to do this is we are going to substitute 21 for x. So we know x equals 21. We are going to substitute it in any one of these equations. We can pick this first one or the second one. It doesn't matter. You'll come out with the same answer either way. But just for the sake of simplicity, I'll pick this second one over here. X minus 4y equals 12. So we have x minus 4y equals 12. And I know that x is 21. So this is 21 minus 4y equals 12. And then to continue solving for y, we can subtract 21 from both sides. So negative 4y equals 12 minus 21 is negative 9. And then let's go ahead and divide both sides by negative 4. And we have y equals negative 9 over negative 4. The negatives cancel out, so that's just 9/4, 9/4. And there we go. Right up here, we solve for x. X is 21. And down here, we solve for y. Y is 9/4. So we have solved this system of equations. We solved for x and y by adding both of them. And the reason why adding both of them works is because, as you could see in this first step, when we add both of them, these two terms, the positive 4y and the negative 4y, both cancel out. So because they both cancel out, you can add both of them to cancel out the y, and then you're just left with the x in this next step. which afterwards you can go ahead and solve for x. And then once you have one variable, you can easily find the other variable by substituting the x for whatever number you got, 21, and then solving for y, which is 9/4. So that's how you solve a system of equations that way, a system of linear equations. And we are going to explore another way that works for all systems of equations, and that is substitution. So substitution, and how this is going to work is we are just going to pick one of these equations. So which equation do we want to pick? Do we want to pick the first one or the second one? I am just going to pick the first one. It doesn't matter which route you take, which ones you pick. There are different routes to solving this system of equations, but they all lead to the same answer. In the end, you will get the same answer no matter how you do it. So you just pick one, the first or second. I'm picking the first one. So 3x plus 4y equals 72. Let me go ahead and just copy and paste that down here. 3x plus 4y equals 72. And what we're going to do next, we are going to pick one variable to solve for. Do I want to solve for x or do I want to solve for y? And again, it doesn't matter which one you pick because ultimately you'll get the same answer no matter how you do it. But I am just going to choose x. So if I want to solve for x, I have to isolate the x, meaning I will get rid of this positive 4y by subtracting 4y from both sides. We have 3x equals 72 minus 4y. And then we can go ahead and divide both sides by 3 to finally isolate this x. So x equals, so 72 minus 4y over 3, we have a binomial over 3. So this is the same thing. We can go ahead and split up this binomial, 72 over 3 minus 4y over 3. What's 72 divided by 3? So 72 divided by 3, that comes out to 24. So 24 times 3 is 72. So x equals 24 minus 4 over 3y. So we've solved for x, and what we're going to do is we're going to substitute this 24 minus 4 over 3y in the other equation that we didn't pick. So this equation right here. So let's bring this equation down. Let's bring this equation here. And what we're going to do, for x, we are going to substitute that for 24 minus 4 over 3y. So x will be 24 minus 4 over 3y. And we'll bring the rest of this down. Minus 4y equals 12. And we can combine these like terms, minus 4 over 3y and minus 4y. But we are adding, or we're actually subtracting fractions right here. Negative 4 over 3 minus 4. So we need this 4 to be in fractional form. The least common denominator is 3. So negative 4 is the same as negative, so negative 4 is the same as negative 12 over 3. So there we go. So let's keep writing this down, 24. And then minus 4 over 3y minus 12 over 3y is minus 16 over 3y equals 12. And let's keep solving for y. So let's subtract 24 from both sides. We come out with negative 16 over 3y equals negative 12. And then to finally solve for y, we're going to multiply both sides by negative 3 over 16, the reciprocal. So times negative 3 over 16. So the negative 3 will cancel out here, and the 16 will cancel out there. So we have y equals, so negative 12 times negative 3 is negative 36. Or negative 12 times negative 3 is actually positive 36. So 36 over 16 on the right side. And this simplifies to, We divide the top and bottom by 2. That simplifies to 18 over 8, which simplifies to 9/4. So in other words, y equals 9/4. So we solve for y, and it becomes very easy to solve for x, because all we have to do is take any one of these equations, and I'll go ahead and just take this one, x minus 4y equals 12. So x minus 4y equals 12. And we are just going to substitute the y for 9/4. So x minus 4 times 9/4 equals 12. The 4 and the 4 cancel out, so on the left side we are left with x minus 9 equals 12. We'll add 9 to both sides. And we have x equals 21. And there we go. We've solved for x and y. X is 21, and y is 9/4. And those were the same answers we got last time by adding both of these equations. So we got the same answer by adding both of them and also through substitution. But substitution will help you solve any linear equation. So that is how you solve this particular set or this particular linear equation. And what I want to do is just go through a couple of more examples. Sometimes you'll come across linear equations that actually don't have solutions. Not every system of equations will have solutions. So for example, if we had x equals 8 minus 3y and x plus 3y equals 6, and then we were asked to solve this system of equations. So let's go ahead and solve by substitution. So let's say we pick this one right here, this first equation, and this one is actually already solved for x. So we can plug in this 8 minus 3y right here. So the x we're going to substitute for 8 minus 3y in the second equation. And then we'll write the rest of it plus 3y. So plus 3y. So plus 3y equals 6. And what happens is you have a minus 3y and a plus 3y. Those two cancel out. And you have an 8 equals 6. So you're left with a very strange answer, 8 equals 6. And that's not true. 8 does not equal 6. So when you come across a nonsensical answer like that, that tells you that this system of equations that we started with, it has no solutions. There are no solutions to this system of equations. There is no combination of x and y values that will solve this system of equations. So that's very important. Now let's go through one more example. Let's say we had x plus 2y equals 10, and 3x plus 6y equals 30. And we wanted to go ahead and solve this system of equations. So I'll solve it by substitution, and what I'll do is I'll pick the first equation, and I will solve for x. So we have x plus 2y equals 10. So to solve for x, I'll subtract both sides by 2y, minus 2y and minus 2y. We have x equals 10 minus 2y. So x is 10 minus 2y. So I will plug that in here in the second equation. 3x plus 6y equals 30. So 3x plus 6y equals 30. And I'm going to substitute that x for what I solved x for here, 10 minus 2y. So this comes out to 3 times 10 minus 2y. So that's what I plugged in. And then plus 6y equals 30. And then to continue solving this, we will distribute the 3. 3 times 10 is 30. And 3 times negative 2y is negative 6y. And the rest of this is plus 6y equals 30. So what is minus 6y plus 6y? Well, those cancel out. And in the end, we are left with 30 equals 30. Now, 30 equals 30 is a true statement. Once you get to a true statement like this, where 30 equals 30, although we didn't solve for x and y, because 30 equals 30 is true, that tells you that this system of equations that we started with has infinite solutions. It has infinite solutions. And the reason why it's different from the system of equations we did previously is because in this system of equations, we came out to 8 equals 6, which is not true. But in this system of equations, we came out to 30 equals 30, which is true. So because this is true, there are infinite solutions. And because this is not true, 8 equals 6 is not true, there are no solutions. So not every system of equations will have solutions. Sometimes you can't solve for x and y. Sometimes they will have no solutions, and sometimes they actually have infinite solutions. So I hope this video helps to understand how to solve systems of linear equations. If you have any questions, please leave them down in the comments below, and thank you for watching.